but like if I turn the lid off, you can't see the marker. If I keep it on, there's a glare. Okay, number 1. Multiply binomials. This is what we went over yesterday. Alright, so when you did your double distribution, what did you end up with? Anybody willing to share their answer? Okay.
X squared plus 2x minus 8. Or wait, are you talking about?
Yeah, like do the right before that.
Oh, okay, yeah. X squared minus 2x plus 4x minus 8.
Perfect. Very good. Anybody have a question about how she got that far? X times x, x times -2, 4 times x, 4 times -2. And your next step, what was it?
Yeah, it's x squared plus 2x minus 8.
Combine the like terms in the middle. There's your answer. Very good. Number 2, 5m minus 2, m plus 9. Somebody else, what'd you get for your first round of distribution?
I got 5m squared plus 45m minus 2m minus 18.
Very good. So our final standard form polynomial, 5m squared plus 43m minus 18. Who else got those same numbers? Yes. Number 3. Y plus 5, y plus 5. Can anybody tell me how this could be written differently? Andrew? Yeah, so a lot of times this is going to be typed up like this. And people misinterpret it. They think it's y squared plus 25. It's a big misinterpretation. All right, so somebody else. What's your first round of distribution here? What's your name? Liliana? Go ahead. Valeria. Got it. Okay, go ahead. All right, so we got y squared plus 10y plus 25. Very good. Does anybody know the name for this polynomial? Why not? You think you got it? It's a trinomial, but it's a special trinomial. We call it a perfect square trinomial. And recognizing that, I won't test you what is a perfect square trinomial, but the more you hear it and see it, the more you're going to memorize the pattern. So every time you square a binomial, you end up, this last value is a number that square roots. It's called a perfect square. So this is a perfect square trinomial. It's a perfect square. And every single time it holds the same pattern. If you take the number here and the coefficient here, you multiply it together and double it, that's the middle. So 5 times 1 doubled is 10. That pattern holds true every time. This is always a square rootable number, and this is always the numbers multiplied and doubled. Last one. Okay, somebody who hasn't gone, what'd you get on your distribution? Anybody? Yeah, what's your name again? Tyler, go ahead. Okay, and we have these opposites in here that cancel out, leaving x squared minus 36. And that's going to happen every time you have a plus sign and a minus sign in the same binomial. Every time you end up with a canceled middle term. This one has a name as well. It's called a difference of two squares. Because difference, because it's a subtraction sign, and it's called two squares because these are perfect squares. Again, 36 can be square rooted. That's not a coincidence. It happens every time. These are the same number. Any questions on those? Okay, number 5. Why do the simplified expressions in 3 and 4 look different? Yes.
Both sides are both positive.
Uh-huh.
And so the difference is that in number 4, both numbers aren't positive. So that's why the answers are different.
Very good. Nicely said. Number 3, trinomial has the same sign. In number 4, the result was a binomial. And that comes from different signs. Okay, so the trinomial was created from same signs in the parentheses. And the binomial was created from different signs in the parentheses. And knowing those patterns are going to be very helpful. More than just knowing how to FOIL and distribute, starting to see patterns is what's really going to help you